All right. Hey, everyone. Good morning. Hope you're all enjoying the conference so far. Nice to see you here. Looks like an intimate group, so happy to make this somewhat of a discussion as well. So feel free to jump in whenever you like. Thanks to the Øredev team for putting this all together. It's been an amazing conference so far for me, and also thanks for the kind invitation. I want to take you on a little bit of a journey today of a concept that was pretty hyped for a while, the data mesh. Now I feel like it's gotten a little more quiet, but nonetheless, the core principles, in my opinion, still very much apply and can be very helpful to make sense of your data and ultimately leverage your data in your organization to create customer and business value. Before we get into that, I just want to tell you a little bit about me. My background is somewhat all over the place. I once studied music and economics, then dropped out of college to start my own business, where I led the product development side of things, and we essentially pivoted our way to ultimately building advertising technology, as I feel a lot of companies did during that time between 2013 and 2020. At the heart of what we built was a few machine learning algorithms that were pretty good at figuring out how to distribute ad budget across multiple creatives, target groups, and channels for maximum returns. Ultimately, we sold that software to a marketing agency from Berlin, and I went over to the other side, helped them a little bit to integrate our software into their broader suite of products and services. Fairly quickly learned that agency wasn't for me, so also left them again and defaulted to what I would call solo consulting, mainly focusing on helping startups and scale-ups to build data and product teams. And of course, the concepts of the data mesh came up a lot of times because some of the problems that we will also talk about today were omnipresent in a lot of the companies that I worked with, and applying the principles of the data mesh helped us and a lot of times to make sense of that and ultimately arrive at that business outcome that we were looking for. Then just this year, I took on a new role leading the product side of things for the global AI team at HelloFresh, one of the leading meal kit delivery services. In that company or in that team, we built the foundational infrastructure for everything machine learning and data science at the company, but we also develop end-to-end a couple of what we call foundational models when it comes to customer understanding, price elasticity, customer behavior, which then other more decentral teams in the company can build on top of to build recommendation or personalization algorithms and ultimately improve the customer experience. All right, now you know a bit about me. I don't know much about you. So I brought just two questions really quick to know a bit where we are in this realm, and maybe I can calibrate a little bit what I'll be talking about also to where you are in your journey, in your organization's journey with leveraging data to make better decisions. So first question, who here thinks that they require reliable data for most of the decisions that they make at the company? Just quick show of hands. Oh, I think this might actually be everyone. Duh, it's obvious, I know. Second question, though, and that will be also the last one. Do you also think that most of your data in the organization is actually reliable, meaning you have a clear data contract or some kind of service level agreement so that you can make those decisions? Who thinks that is the case? Ooh, there's 2-3 people. So there's a big gap. That is good news, because if you said yes to question number 1 and no to question number 2, that talk is for you. If you didn't, well, maybe it's still interesting, but let's see how far we can get. Cool. So what can you expect over the next 20 minutes or so? Essentially, in that journey that I mentioned, I want to talk about 3 things. I want to start with why, and figure out why should you even be thinking about something like the data mesh. What are maybe some problems that you experience in your organization that might make you think, maybe it's time to change something here. Actually, I don't really feel that I get the value of the data that we have. Then we quickly talk about what is it? What is this more theoretical concept of the data mesh? And then lastly, but definitely not least, how can you apply it in practice in your organization? Okay, why should you listen to any of this? I brought essentially 3 pain points that I want to talk about. And one is, actually, it's a good thing, right? We all want to grow as companies, but growing sometimes can be painful. When you grow as a company, as an organization, usually the volumes of data grow with you. And that can lead to a lot of stress that you put on maybe some infrastructure that you've set in place at your company when you were still 3, 5, 10, or 20 people. So once you then not double, but maybe 10x the volume of folks in your company, customers, also the data grows with it. And that usually leads to the architecture that you might have put in place in the beginning not really working anymore. And one of the biggest problems also that I've experienced with a lot of the clients that I worked with is a lack of awareness. Like people were producing data, putting it somewhere in, well, what in the beginning maybe was a very clean data lake and then turned out to be a pretty muddy swamp after a while. And they were not even knowing like who was actually using the data, who were the consumers, and how was the lineage graph evolving in the company. Then there's another common problem that I've seen a lot with companies growing, and that is around business intelligence or analytics. Usually companies start maybe with 1 or 2 analysts. They are somewhat centrally organized. Sometimes they're attached to the finance team, sometimes the product team, maybe even the sales team. And then the leadership of the company, growing bigger and bigger, wants to make data-driven decisions. Well, that's great, right? Like we want them to make data-driven decisions. However, that then leads to them asking those 1, 2, 3 BI folks or analysts a lot of requests. Like, can you find this data point for me? Can you create this visualization? I want to see how our revenue grew over time. Or maybe even a bit more advanced, can you maybe forecast this particular time series in the future? How will the revenue develop in the next 6 to 12 months from now? These are, I think, pretty standard questions that a leadership team would ask. However, then you can put more people into that central data team. It will grow, but ultimately you need to organize those requests, you need to respond to them, and this leads to decisions just taking longer, and with that also the company taking longer to develop meaningful insights that will ultimately help them grow the business. And the third point here is very related to the first, like more and more data also usually leads to a lot of load on your infrastructure. Like I've literally seen teams build Tableau dashboards that took more than a minute to load. Like who can work with that? That is no fun for anybody, but yeah, that is happening. And maybe even worse, maybe you have some SLAs in place with some customers and you are also violating those. That might even be more detrimental to the business. So first problem set, failing architectures because of growth. Then the second is, it's about inefficiencies. You've probably seen that like once a company grows, there's more and more data, and it's hard to find the data. It's hard to discover the data. And the data team, oftentimes data analysts, but this can also be data scientists or data engineers. A lot of that time, I've actually seen more than 50% of the time, we did surveys within companies that I worked with, and sometimes up to 80% of the time of the whole data team was spending to find the right data assets, to prepare the data assets for what they actually wanted to do with it. And that was not time spent on actually deriving or getting the insight or building a product that would ultimately deliver some outcome that the company was interested in. And the second thing is data downtime. What is data downtime? I define it very simply as any time your data is not in the expected state. That could mean the data is wrong, the data is missing, or it's in the wrong place. And that is something also with growing team sizes, more and more teams popping up, pushing their data into this data swamp, other consumers picking it up, this lineage not being fully mapped, the producers not knowing who's consuming the data. So what happens? Well, maybe some dashboard has a number, the CEO looks at it every day, and he's like, this looks off. Because to some of the analysts producing that dashboard, well, the dashboard queries, everything seems to work. Why could this be off? And they go to some engineering team, which maybe is responsible for providing the data asset that ultimately make up this dashboard. Then, well, they don't know, like we're picking this data up from somewhere else. We don't even really know from whom. And then this just takes a ton of time. There's a lot of time spent just fixing fires, fixing incidents, which is not really spent on driving the business forward. So failing infrastructures and inefficiencies, and this is the last problem, or rather an opportunity which is missed, which I think is maybe even more important, because as teams are dealing with those two issues that I described, they're actually not spending time on leveraging the data to come up with hypotheses that they can experiment with, that they can test for new ideas and to iteratively improve the products that they are building. Or if we then even go a bit further, we can use and leverage data to build machine learning models and to optimize our products, to personalize, to create better customer experiences. This, in my opinion, is really what data is helpful for. And if we spend a lot of time, or our team spend a lot of time on fixing breaking architectures and finding the right data, mitigating issues, then we are not actually getting to this third part where data is actually helping us to drive business outcomes. Okay, so these are three different problems. Let's look at the other side. Like we have the problem state, which oftentimes is the status quo, but where do we actually want to get? Which I think is also an important part of the why, to look at the outcomes that we want to drive. Probably most of us can agree that we would like, or we would be satisfied with faster decisions, better decisions, and new discoveries. And I think it's important then to also figure out, think about the data mesh as a concept and how can you measure success of something like that. And I know like we haven't spoken about what exactly is the data mesh yet, but we'll get there. And hopefully you will then see that the data mesh as a concept or the principles applied in practice help us to drive those three outcomes through a bunch of key metrics that we can track. Hopefully we will be able to get to insight faster. We will spend less time on preparing and finding the right data assets. We will not have as many data downtime incidents, or if we have the data downtime incidents, we'll be able to fix them faster. We will increase reliability in our data, and that both from a technical perspective, but maybe even more importantly, from a business perspective. Because the worst thing, in my opinion, that can happen is business leaders that are very keen on making data-driven decisions. They want to use data to figure out how to steer the business, but then they run into situations like, I see that number on dashboard A and I see the same number on dashboard B and they're different. So can I trust, which dashboard can I trust? Can I even trust any of the data here? What are you guys even doing? And then this all goes downhill. They start not really trusting the data. They don't start trusting, or they stop trusting the data teams. And this whole idea of really making data-driven decisions to arrive at better outcomes goes down the drain. And then lastly, also mentioned that briefly already, we can use data to get to more experiments, which helps us iteratively improve, and also to optimize customer experiences, to optimize parts of our product with machine learning or also traditional methods. It doesn't always have to be ML. Okay, let's park that for a minute. We've talked a bit about problems and what we actually want to achieve as a data team or with data in any kind of organization, really. So now we can talk a bit about the data mesh, and then lastly, hopefully, we can see that some of those principles help us mitigate the problems that we've seen before. So I will go to those 4 different principles of the data mesh, just to motivate this a little bit. Maybe some of you, most of you probably have heard where this is coming from. So Zhamak Dehghani, who was a consultant at ThoughtWorks at the time in 2019, I believe, like she saw all of those problems, a lot of those problems that I just showed you with the clients that she was working with as well. And she was thinking, this sounds awfully familiar to what we have seen in the software development world already. It sounds like we have centralized teams, they become bottlenecks, we grow like in somewhat of a monolithic architecture, which really doesn't help us scale well. And there was a solution, at least to that in the software development world, which is microservices and which is decentralization. So she was thinking, can we apply this also to data and to the more analytical workloads and use cases that we have in an organization? And that's how she came up with this idea or paper in the end that was published, I think like somewhere in mid-2019, which postulates those 4 different principles. And I'm taking a little bit of my own spin on that here as well, as like people who are very familiar with the space will notice that, for example, the first 2 are swapped, and I'm starting with a different first principle than she did in her article. Well, that is why, because I believe that is really the most important starting point here. Thanks. All right. So what is this first principle? What does it mean? What does data as a product mean? So as a product, first of all, I have a product background. So the most important thing in product management, in my opinion, is customer centricity. So this starts with figuring out who are my customers? So who is using this data that I'm producing? What are their needs? And what can I do with whatever I am providing that serves their needs? And ultimately, we achieve that by discovering ways to get there and mitigating 4 different product risks. The first is customer value, like this is this one, like how can I serve their needs? Then there's also usability, and that means can the people who use the data or the data products that I produce in a way that makes sense to them. And that can be a user interface, it can obviously also be an API, maybe it can be different AIs talking to another. This doesn't really matter, but it has to be usable for the particular use case you're going for. Third one is feasibility, right? So like we want to make sure that with the development team that we have or the data team that we have, we want to build products in a way that we can actually achieve with the capacity or with the resources that are available to us. And the fourth one is business viability. Of course, we also want to make sure that whatever we do is aligned with the company strategies and also drives business outcome ultimately. So those four, value, usability, feasibility, and viability, like the four main product risks, we should also apply to data, and it's very feasible to actually do that, in my opinion. Then the second one, we talked a bit about this, is this whole like microservices idea. Can we decentralize the ownership? Can we create domains and define boundaries of different data assets that we have, products that we have, and put together a set of people, a team that can own end-to-end the value, discovery, and delivery for a particular product or data asset in this case. And that means in the software development world, we have seen that means putting different skill sets together in a room. So like have front-end, back-end, data science, design, product management work together in cross-functional teams. And that very much also applies to data. We could even expand those teams, add a data analyst, add a data engineer, maybe add a machine learning engineer if you build an ML product, so that they can really create value end-to-end with as little dependencies, as loose coupling as possible to any of the other domains. I think these are the two most important pieces. And then Jean-Marc like sprinkled a little bit around that, which also makes sense. Like she said, okay, like we don't want anarchy. Like everybody is doing whatever they want. We need some kind of global understanding, some common values, some common principles. How do we govern the use of data in the organization? So that is what this global standards stand for. And we had an interesting discussion, I think, last night with some of the other speakers here, where someone pointed out, yeah, like ideally this should actually be computational governance, which is true. I actually purposefully leave this out here because I feel like a lot of people, like if they try to get there in the first step, they will fail. So I would rather have them write down some of the principles, put this in a Google Sheet, I'll put this somewhere. You can also put it in code, this is fine. But enforcing that through computational governance is really hard. And this, I think, is a bit too early to get there in the beginning. That's why I just leave it out in like the first four principles here. And then last but not least, and that is also very similar to the software development world, we want to create some layer, it can also be a team, that develops a platform, which essentially is a set of tools that all our different data teams can use, that makes them more efficient, faster in their development, and hopefully also develop more reliable and better data products. And when we get to the how part, I will point out a couple maybe lower-hanging fruits, like some of those tools that you can build in your organization as well. So let's get there. If you remember, like we had those three problems: failing infrastructure, inefficiencies, and then what I pointed as the sky is the limit. Like we want to use data to actually drive experimentation and create business value. And then we were talking about the outcomes that we actually want to achieve. So those outcomes are the same ones here that we can track, because we, as I already mentioned, should also use the data mesh somewhat as a product and figure out like who are the customers of the data mesh. Well, these are the different teams and ultimately the whole organization. So how can we track that we serve their needs and make something better for them? Well, if we can prove that we reduce the time to insight, so make better decisions faster, that we spend less time on data wrangling, preparing, finding the right data, reducing downtime, increasing reliability and trust in data across the whole organization, so everybody feels better when they make data-driven decisions, and we run more experiments, so we learn and iteratively get better. That is how we can measure that the data mesh actually works. I think that is what we should hold ourselves against. Like, for example, if you guys want to pitch some of these in your organization, like don't say, hey, data mesh is cool, like ThoughtWorks says that we should do that. But it's like, hey, like, we will actually report on those things, and we can prove that with some of the principles applied in practice in our organization, we drive the outcomes that we all want. So how can we do that? Well, there's a lot of stuff on this slide here, but the most important thing, and that I think also comes from Jean-Marc's original article already, she calls the data mesh is a socio-technical concept or socio-technical approach. I would almost scratch the technical. I think it's not very much a technical approach, because it's very much about this. It's about creating an organization that works, that has those independent or as independent as possible, cross-functional teams that are oriented around domain ownership. And in some company that I worked with, we actually went even a step further. We went beyond the product team. A product team meaning engineers, designers, scientists, analysts, product folks in one team. What we also created, what we called their value streams, where we integrated commercial functions into those domains as well, namely customer success and customer acquisition. So they were all working together, and we really had the full stack. So it was almost like small little companies working together under a bigger umbrella. And that's actually something that I tell my teams even today sometimes is, like, think about this other team that you're dependent about as if they were in a different company. How would you work with them? How would you draft up a contract, an interface that works together? Because this tight coupling is really what slows us down, which we've also seen in the software development world. So that is something I'm also trying to apply to data and to a more holistic organizational architecture. Also, probably most of you have heard of Conway's law, maybe not another name, but that states that the output that a system can produce is very much constrained by the organizational structure that I've seen be true so many times. So this is really the starting point. Unfortunately, that means you need to get buy-in from a lot of people from the beginning, usually, because it's very hard to change this in a very narrow domain or just in one domain. You need at least two. At least, let's say that. You do need the whole company to change. Obviously, that is like an endeavor that will be set up for failure if you want to start there without proving your way and like actually iterating and proving success with those success metrics that we've seen. But you need some kind of buy-in that this might be the ultimate state you're working towards, or that you work backwards from applying those principles today. After organization, another thing I think that's very important and that addresses a couple of the problems that we have seen earlier is around data observability, or sometimes also just called data quality. And how can you create more awareness and visibility into the data, making sure your data is reliable and can be used across teams and can be shared, well, usually with some kind of contract. And contract here, it's a big word. But it doesn't need to be much, right? I think I mentioned earlier, it could be a Google Doc that you set up. It can also be something like we are now using a data contracts in Git, which also works pretty well. And usually what teams do is they define a few data observability metrics between the data producer and the data consumer, right? So one team is producing data, another team is using that. First of all, it's great to identify that this relationship actually exists, because before that you can also not set up this contract. If it exists, it makes sense, in my opinion, to write down, like formulate a few expectations to that data that is being used. And those expectations usually go somewhere around those 5 different metrics. Like you want to make sure that there's an expectation around when does data arrive? Like, is there new data every hour? Is there new data every day? How are the values in this data set distributed? I've also seen this distribution piece just called data quality, which I find very confusing. So I like distribution because essentially this, like if you imagine a table, it means in this column, how many null values do I expect, or how else do I imagine the distribution if it's numerical values, like what's the median, what's the average, how's the distribution, the data distributed, the values distributed across this particular column. Volume, how many rows. Schema is the one that I've seen like most people actually do. Usually they start there because I think it's also clear why, because things really break if the schema is not in place. The problem is a lot of big issues arise when things are not actually breaking, but they are wrong. And you might not know this. So maybe there is a couple more null values and like there's not a clear validation for that. There's not a clear data contract, especially it's not computationally enforced. Then those just gets like permeated through. So like something might be wrong, then it's wrong in the machine learning model that uses it, spits something out. You cannot even tell really anymore where does it stem from. So that's why I think this is really important to have those data observability checks essentially for every handover, for every interface between a data producer and a data consumer. Yeah, sure. Mm-hmm. Yeah, I think it's a really good point. It's like it speaks a bit to some kind of a catalog, maybe like where other people can discover data products that exist and how other people are using them, to your point, but maybe also how they are using them. And yeah, that is actually something I think is a really good point. It's hard, I think, to put this in a contract between just the producer and the consumer. It's more of like a meta store around like what data do we have, which I think is very valuable. For example, in the machine learning world, a feature store is a classic example of that, where you show like how are different data sets used as features into machine learning models, and also what the predictive power that some of those features have for those models, for example. And then other teams can discover that and see, okay, like if they're using this feature set or feature view in their model, maybe that also applies to mine. And if you have the platform set up in a proper way, well, they can just plug this in and see, does this actually increase the performance of my model? And that's very valuable. So yeah, very good point. And yeah, we haven't spoken about lineage. Lineage is also not part actually of the product, of the data contract, sorry, because the data contract is just between two people usually. But lineage then is also some of these meta concept where it shows you actually how is data being used across the organization. Okay, the last set of tools or ideas I want to give to you are some of this, you remember this bottom layer, the infrastructure, the platform. And we talked about the different domains, how do they interface, a bit about standards, but what are some easy to implement tools? And yeah, thanks for the question data catalog. It's actually the first one that I listed here. It's really make it visible what data does exist and how can it be used across the organization. Another one that I've seen actually be quite easy and a fairly low-hanging fruit to implement is some kind of monitoring platform. It always sounds more difficult, I think, than it ultimately is. Like one client that I worked with, what we did there, essentially we built a service that allowed data-producing teams to run SQL queries on a schedule. It was very simple. Like they run some query, they had some expectation against that query, and then we would create an alert if the expectation wasn't met and send this to Slack or some of the other tools that this team was using. And that really helped them a lot, relying more on the data, not having to check every day themselves, and then also being able to fix something before even some of the stakeholders or some of the customers of that data product would be aware of it. Visualization, dashboarding, of course, you don't have to build your own dashboarding tools. There's lots out there, like Tableau, Metabase, and others. Experimentation platform is a little more tricky, but also there I think you can get started fairly quickly. If you want teams to experiment a lot, I think you should let them. One of the things, or maybe the first, that I would say makes sense to figure out some synergies, maybe centralize a little bit, is, for example, the statistics engine. Like not every team needs to build their own way to figure out significance levels or confidence intervals or base factors, like whatever school of statistics you are following. I think that is something that makes sense to also centralize somewhat from a platform, but also from a global standards perspective, that people in the organization know what does it mean if someone says, oh yeah, this experiment or this test was statistically significant. Data contracts we talked about already. MLOps, I also mentioned that. The feature store, I think, is a good way to get started there. Others are development environments where you don't necessarily also have to build everything. There's vendor solutions that you can use here as well. And then another one is more around guidelines, how to manage incidents. Like obviously, I think you would have that for the engineering folks, for the software development. Like why not also for data? What happens if there's data downtime? There should be some post-mortem that you create and some way like to ask the 5 whys, for example, and figure out what can you do that this doesn't happen again. Okay, we are at summary time. So let's recap. Why would you need something like the data mesh? What actually is it? And how could you implement it? I mentioned 3 different problem statements for the why. Like we put a lot of load on legacy architectures. They might be breaking. We are inefficient with our resources on the data practitioner side. And we're missing opportunities in terms of incrementally experimenting, getting better, and potentially building systems to optimize and personalize our user experience. Then what is the data mesh? Well, it's a concept to use decentralized data products, and I put a bit of standards on top and some infrastructure on the bottom. And how do you do that? First, it's an organizational concept. So we want to create this ownership, this end-to-end teams. I think that is something to keep in mind, those cross-functional squads. Then observability as a concept is something you can apply very easily from the get-go. And then there are a few tools where you can pick and choose from. It's not like you don't need all of them. Start with one or two. Measure with the different metrics, with the outcomes that you want to achieve, if they're actually getting you where you want to get. And then from there, iterate and collect feedback. All right, I think we have probably some time for questions. Thanks a lot. Go ahead. Yeah, it's a good question. Right. So the question is there like a minimum size of the organization or the team for this to really work? I think the problems, or the magnitude of the problems that I described, they correlate with team size. So I think the problems get bigger when the team grows. I'm not sure if there is a set minimum size. I think if you have only one engineering team and then you maybe have a data analyst and data engineer, you can put them in one team. I don't think a lot of this really applies to you as a company. So probably there is some size of like 10, 20 people where it makes sense to start thinking about this, especially if we approach it from this organizational or culture's perspective. I think still the principles of like treating the data as a product also depends a lot on what type of company are you. Because if the ultimate product that you provide to end consumers is actually a data product, then maybe you can actually apply some of those principles on that interface, but maybe not if you're a very small team, not so much in between, because then breaking up the team just actually creates extra dependencies and like coupling, which I think then hinders the ability to really accelerate and grow fast in the very beginning, which is something that then later you will actually get much more benefits. You will have more lever around this. Yeah, go ahead.
You mentioned data catalog. I'm still waiting to see a successful implementation of a successful data catalog. Not because there is a lack of tools, probably on the contrary, there is an ocean of data catalog tools. But I guess what you mentioned is it should be possible to find different data assets and components, understand, but how to succeed in discoverability of data products.
Right. So the question is, how do we make data discoverable with maybe a lot of like data catalog solutions out there, but how can they be implemented effectively, successfully in an organization? One problem or one, I guess, pushback from teams that I have seen is around, well, this is extra work, right? I need to register my data somewhere. Well, I need to, like someone needs to go and do that. So I feel that it's about incentives. So why should I go register my data? Well, maybe because I want to also subscribe to some of the data that's in there. That is actually something what we have had quite some success with the feature store. Again, going back to that example, it's like, please like put your features that might be valuable for others in the feature store, because you will also benefit from getting some out of there. And then like really creating this culture of, we contribute and we take from it, like a give and take. That is something, of course, you could potentially enforce it. We didn't. I think usually I try to rather create good incentives than creating too many rules for engineering and data teams. But that is one way I've seen this work. I think the other is probably more of a holistic business thinking and business acumen in the teams. That is like not so much about only driving value for this particular domain that they are part of, but they are part of a larger organization. So ultimately, I think all succeed. So this could be very top-down incentives, like give everybody equity, then they should be interested in driving the outcome for the whole organization, so that they see that they register some data asset to the catalog, others are being able to find it and use it and do something valuable with it, that ultimately everybody benefits. I mean, it sounds a little esoteric, but I think this is actually more a cultural exercise and an inspirational exercise the company has to go through. Go ahead.
So kind of a continuation of this, like as I interpreted, kind of a motivation for the teams to do it. How do you prioritize the work? Create a data product in an enterprise environment where you already have data on sets that people want to have access to. how do the product teams prioritize creating data products? Because it's very possible that no one will ever use the data because your data is so niche that no one wants to touch it. Like, how do you prioritize this work?
Mm-hmm.
Because you could always go to them and say, hey, you are going to get money or whatever. Give the company higher budget to put it in their register. But how do you know if that's going to happen?
Yeah, I think I hear two questions in there, like how we prioritize, and then the other was is like, what if no one is using it? Maybe let's start with that one. I think if you create or develop a data product and you think this should be used by others and it's not, then the product manager didn't do that job well. So that is something I would like, again, like customer centricity. We should start there, like figure out the use cases before even building anything. I think that is maybe a coaching opportunity in that organization. The other is like, how do we prioritize? Like, I don't want to get too much into other concepts or leadership or any kind of principles, but I had it on one slide is OKRs, objectives and key results, which I've seen actually quite effective and as a measure or a means to align overall company strategy with the incentives for the individual teams. So you can think about maybe the company has a set of OKRs and they can be annual or quarterly, and then you encourage the teams to create their own set of KRs, but they need to be leading indicators into the company KRs. And if one important, let's say there is an overall like data organization KR, which is about creating more observability, creating more visibility, or reusage of data assets. For example, like one of my data team's KRs is reusage of feature views. So they have a clear incentive to deliver against this outcome that we have to find together. And yeah.
Kind of like continuation.
Okay, yeah, I mean, happy to follow up also offline. I think there was, maybe we can take one more question. Yeah. Yeah, that's a good question. So, like, how can we drive this change? Can this come from one smaller team, or is this something that needs to come top down? I think it's a bit of both. I think if a team voices their concerns and they bring them in clarity to data leadership, or like, I don't know how big the company is you're talking about, I think you will need, as I mentioned earlier, some kind of buy-in to make a change. But I would hope that that is generally, I guess, part of the DNA of fast-moving companies, that they embrace change. So I would very much encourage teams to identify problems, and essentially you can think about this like a pitch, either you're using narratives, so write a 6-pager like Amazon does, or you actually do a little pitch deck, say, hey, which is what we did for one of the companies that I worked with as a consultant. We actually, with the central data team, we put together a pitch deck for the C-level and the board, where data measure was one part, but we created more of a holistic data strategy. But those problems that I mentioned, they were like literally slides in there. Like we are seeing failing infrastructures, we're seeing this, we're seeing that. Like we will have many more opportunities if we're actually able to move faster and make better decisions. And that is a way that we would suggest to address those problems. Is that something that you feel we should fund? And they said yes, so we actually got quite some resources then to go do that. All right, I think we are probably at time. Thank you very much.